We are on slide number 11, and in this slide CQI CH channel is explained. Mobile WiMAX mobile station uses channel quality indicator channel, which is called CQI, to provide the base station with channel quality information. So this particular channel, which is present in uplink frame, has all information related to channel quality of the mobile station. Basically, this contains the C2I, the RSSI, and other channel quality information that base stations require and mobile station reports. Both the mean and the standard deviation of the RSSI and an SNR are included in the definition of channel quality information message. Base station can either or change modulation or coding rate for the transmission based on the CQICH channel, or change the power level of the associated downlink transmissions based on the CQICH channel. We are on slide number 12, and mobile WiMAX supports concepts of ARQ and HARQ, and layer 2 ARQ, which is also called automatic repeat request, supports link error control, and ARQ is reliable link over wireless channels, and ARQ is also suitable for delay tolerant traffics. Mobile WiMAX supports HARQ and HARQ or hybrid HARQ. Uh, um, Supports robust and is robust and against rapid changing channel conditions, and also helps in improving MCS errors. Layer 1 HARQ maximizes channel 1 capacity. The current version of the mobile WiMAX release 1.0 supports chase combining based HARQ, and there is also an next version which is called incremental redundancy, which can be also supported based on requirement of an operator. On slide number 13, and link adaptation, automatic link adaptation is one of the methods which is supported in mobile WiMAX MAC, and link adaptations is based on channel conditions, and it also maximizes the capacity of a sector or a base station, and also stabilizes the link operation. So link adaptation is based on either the receiver's channel condition, or it could be based on CNR, RSSI measurements. It could be based on instantaneous capacity of that particular link, or number of retries, or packet error, or drop, etc. Or it can also be based on prediction of MCS in the next frame, and also has an relation to QoS requirement. So mobile WiMAX supports automatic link adaptation, and link adaptation helps to improve capacity of a sector, and the adaptation of link is a function of one of those things, or number of conditions like CNR, RSSI, QoS requirement, and PER. Power control is a mechanism that overcomes the propagation losses variations, and which arises due to change in distance, shadowing, or fading effects. Power control mechanisms also helps in overcoming near far effects in uplink, especially called party effects. So it's like if a mobile station is very close to a base station, so so and if it is very close to a base station, if there is no power control mechanism which is allowed in the base station or supporting the base station, so it can generate an effect of a party effect, and in which it can actually stop the communication between the base station, and also creates a lot of interference. Power control mechanisms helps in optimizing overall system throughput by controlling modulation and coding schemes, and uplink power control mechanisms especially helps in improving overall sector throughput by improving overall modulation and coding, and which in turns helps improving the CNR, and which in terms will be driven by the transmit power. So So power control is an efficient method to control interference and improve systems throughput. And power control also helps in maximizing battery life for mobile terminals, um, and and with reduced power consumption, the battery life of a mobile station or mobile devices can be improved. So in nutshell, power control mechanisms helps in overcoming propagation losses, improves system throughput, and also maximizes the battery life. There are two types of power control mechanisms which were defined in WiMAX 16E, and one of them is called open loop power control mechanism, and other is called closed loop power control mechanism. In open loop power control mechanisms, mobile station determines its transmit power to meet the target C2I or target modulation, and that were broadcasted by the base station. So base station periodically broadcast C2I condition of a mobile station, and based on those C2I which is seen by mobile station adjusts its power to achieve the modulation and coding required to support the data rate. In closed loop power control mechanism, mobile station keeps on transmitting until there is a correction which comes from the base station. So after the correction, mobile adjusts its power, and again start the transmission, and then the base station again gives him in power control the request or information. In the below graph, you can see that the blue lines are the transmit power as perceived by the mobile station, and the red lines are the power perceived by the base station. So the mobile station started power transmission, and the base station after a certain instant of time has seen that to achieve a certain modulation, the mobile station has to increase its power. So he sends an correction message in the power control message, and the mobile station controls it or offsets it uplink transmit power. So in this way, a close coordination of power control is achieved between base station and mobile station. Now the next section covers WiMAX handovers, and uh, mobile WiMAX supports optimized hard handover mechanisms, and handovers are initiated either by mobile station or by base stations. Handover can be initiated based on RSSI thresholds or CNR thresholds, and there are different steps in handover, and typically they are network topology acquisitions or the cell scanning, and then neighbor advertisement from the serving base station, and by which mobile station adds its neighboring base stations, and then periodic scanning of the base station, and then association. So on the right side of the slide, you can see when a mobile station does a handover between one sector to another sector, this is called intra-base station handover. And when an mobile station does a handover between one base station to another base station, both of them are parented to the same ASN gateway, it is called inter-base station handover. And a mobile station, when does an handover between a base station to another base station, and both of those base stations are parented to two different ASN gateways, and then this type of handover is called inter ASN gateway handovers.